Okay, welcome back student. Good morning and good evening also. And today I'm going to continue from the last video about this topic force. And today we are doing with Newton's laws of motion. Because we have defined what is force. We already explained that force can stop motion, force can produce motion, force can change the shape of an object, and also force can change the direction of a moving object, or force can increase the speed. But now we will look the definition of force according to Newton, and that will be deal with first law of motion, that is according to Newton, first law of Newton, then second law of Newton, then third law of Newton. We will go first with first law of Newton. What Newton first law said? It says that, okay, it says that when the object is at rest, example when the object is at rest, okay, this is a textbook. Now let's say this is the object. Now this object is at rest. If this object, I'll keep it here, then tomorrow again I'll come and look this object. Will this object move? Doesn't move, because if and unless some person or some other person come and take out this or move this textbook, then this object will remain in here. And what Newton said, he said that the object will remain at rest until and unless some external urgency or some external unbalanced force are coming to act on this object. Okay, example, now this object is at rest. Now this is the force are coming to push this object. Now see, now initially this is at rest. Now when I push it, this object moves. Then Newton said that when the object is at rest, it will remain at rest until, do check that, until and unless some external force are applied. And also, in that same law, not only when the object is at rest, he said that is also, when the object is in uniform motion, when the object is moved with uniform motion, it will continue. If that object, okay, example, this object are moving, this object are moving uniformly, okay, then this object will keep on moving until and unless, like that same part, until and unless some external force are applied on that moving object. But if I make this object move here, in reality, will this object move? It will move for some time, and after that it will stop. Example, if I take marble or so, I will roll it here. It will roll only when I am pushing the force. After that it will stop. That is in reality. But Newton said that the object will keep on moving if it is moved with uniform motion. Then why Newton said that? And why in reality that things does not happen? What? Look, I'll draw a diagram. Okay. Example, this is a floor. Example, this is a floor. Now in this floor, there is a marble. Now I'm pushing this marble once. Once I push this, the example, this is a marble. Okay, now consider initially this object is at rest. This object is at rest. At rest means there is no motion, and there is no acceleration, and there is no velocity. Mean here, velocity is equal to 0. Mean the object is at rest. Then this object will remain at rest. Okay, after some times, velocity v, mean final velocity in time t. Then here also will be 0. Mean if initial velocity and final velocity will remain 0 until and unless some external force are applied, or unbalanced force, or external agency, or another person come and take out this object and push it. Okay, now that is the first part of this law. The second part is that now these objects are moving. These objects are moving with uniform. These objects are moving in uniform motion. Then this object will keep on moving forever. Will keep on moving forever in a straight line. But is that true in reality? Will this marble once you push it, that will move forever? It won't move. Why? What's the reason? And what Newton said this, that the object will move forever, and why in reality that is not happen? Because once we push this object will move. But why this object stop? It stopped due to the presence of friction force. Due to the presence of friction. What caused the object to stop? Friction force. Not only friction. There is a gravity force also. And also the air. When you run, did you feel any air is pushing you back? That also was trying to stop that object. Okay. But that in rolling a marble, that pushing of air, most of the case we neglect it, because that force, that friction force by the air are very, very small. So mostly we consider is friction force, means the contact between the surface of the floor and the surface of the object. That will be the friction force. And what is a friction force? A friction force is the opposing force. What's friction force? Opposing force. What's the meaning of opposing? Oppose means against. If the object wants to move that side, then that force said no, don't move that side. That force is pushing this side. Mean opposite. That is against. Mean object move this side, then some force are trying to push that object back to the back side. That is friction. Mean the opposing force means against. Or we can say as the another word was opposing force. Okay, I forgot another one. Okay. Now, what Newton law said, first law, the object is at rest. The object will remain at rest until and unless some external force are applied. Mean the object will remain at rest. After some time also it will remain at rest. Then when it move, only when we apply force. Then when that object is moved with uniform motion, then that object will keep on moving with same motion. Mean if initially it moved with u, initial velocity, if initially it is moved with velocity u, then after some time also it moves with velocity v. Mean final velocity will be the same as initial velocity. But in reality that things not happen. Once you roll a marble, initially that marble roll very fast, but after sometimes the speed of that marble are reducing or decreasing. Why? What makes that velocity or the moving of that object slow is the friction force. The friction of the caused by the air, that most of the case we neglect it for normal speed. But if for too much high speed, then friction of the air we cannot ignore it. Okay, then now you got what is Newton's first law. It states that when the object is at rest, it will remain at rest until unless some external unbalanced force are applied, or when an object is in uniform motion, it will keep on moving with uniform motion until and unless some external force are applied. We already said that force only can change the speed of the object, force can stop the object, force can produce the motion. Then same here, the definition said that object will be at rest until unless some external force. Then that object is at rest. To produce the motion of this object, we have to apply force. Got it? Okay, let's write the statement. Okay, now we'll write the statement. Okay. Newton first law. Newton's first law of motion. If they ask you an example, state Newton's first law. In class 9, this question they will ask, state Newton's first law. In the high class, rare case they will ask. But only you need to understand is the concept. What is Newton's first law said? You already got it just now. Okay, let me write the first law. It states that what it said? The object. It states that the object at rest or the object at rest or the object moving with uniform motion. The object at rest or moving uniform motion. Okay, if the object is at rest, it will remain at rest. If the object is moving uniform motion, it will keep on moving with same speed. Okay, the object is at rest will remains at rest. The object at rest will remains at rest, or the object moving with uniform motion will remain at rest or will keep on moving with uniform motion. Okay, the object at rest will remain at rest, or the object moving in uniform motion will keep on moving with uniform motion until and unless some external agency, some external agencies or unbalanced force comes to play or apply. Unbalanced force are applied or unbalanced force come to play. Okay. And the object at rest will remain at rest until when? Until and unless some external unbalanced force are applied, or the object moving in uniform motion will keep on moving in uniform motion until and unless some external force are applied. That is Newton's first law. Then I got this. That is U is equal to V. What's the name of this? U is equal to V. Okay, where U is the initial velocity and V is the final velocity. Mean here in this statement, mean force are not acting. There is no force acting. Mean here force is equal to 0. Mean in this case, in this first statement, then force is 0 because we said until unless some example mean the force are not yet applied. Then force is 0. Then if force is 0, then if U is 0, then what is V? Then V also will be 0. That means the body will be at rest it will remain at rest. If force is 0, then if U also 0, then final velocity also will be 0. Then object will remain at rest. Now, if U have some values, example 10 meter per second, if U is equal to 10 meter per second, then according to this, then V also equal to 10 meter per second. That means the body will move at the same speed and same uniform motion. But this is not true in reality. It won't move with same speed. Then here, when these things happen, when the friction force are removed, if friction force are removed, then if the viscous force, what is that viscous force? Viscous force is the force pushing by the air. Okay. If friction force are removed, if viscous force are removed, and if gravity of the earth also are removed, then if the three forces are removed, then the object will move with uniform motion. Will keep on moving with that same speed. If moving uniform, it will keep on moving forever. Okay, that is the first law of Newton's. Okay, then now we come to second law of Newton. Okay, now before we come to second law of Newton, first you have to know about the momentum. What does that momentum means? Okay, let me wrap this one. Okay, now we'll talk about momentum before we come to Newton's second law. Okay, now before we move that, at least do remember first from that first law of Newton. We already give the statement of that first law of Newton that the body will remain at rest if it is at rest, but the body will be in motion if it is in motion until unless some external force are applied. And remember, this first law of Newton's give the definition of force. Which laws give the definition of force? First law, second law, third law. First law give the definition of force. First law means define the force, define the meaning of force. And first law is a law that makes some things that to change the state of rest or to change the state of motion. State of rest or state of motion. This force means the agency that change the state of rest or motion. Okay, now let's talk about momentum. Now, once you understand this momentum, then we'll do second law. Because second law is deal with momentum. Okay, now what is this momentum? In simple terms, we can say in mathematics or in mathematical form, these are very simple by looking. Momentum, the symbol for momentum is P, sum by P, then which is equal to mv. This is the mathematical term. Meanwhile, this is m, mass of the object, and v is the velocity. Means we can say momentum is the product of mass and velocity. But these are very simple. But what do you understand from here? To remember what is momentum? Momentum is mv, mass into velocity. Mean the product of mass and velocity is called momentum. And very simple. But what is the meaning of this and what is the concept here? What do you need to understand here? Because most of the cases, what is momentum? The product of mass and velocity is called momentum. Finish. Okay, but the meaning here, what is momentum? Okay, now let's explain what is momentum. Example here, there is a plate. Let's say this is a glass plate. Let's say this is a glass plate and is placed on top of. Let's say it's placed on top of this block. Let's say this is a block. Okay, let's say now this glass plate is placed on top of this block. Now let's say there is a one object or one metallic object. Metallic object. This object is at the height of, let's say what is height? Let's say here is a 5 centimeter height. 5 centimeter height. Now this object are made to fall on this glass plate. This is the glass plate. Okay. Now this is a glass plate placed on top of these two blocks. These are the blocks. Now this glass plate is placed on top of that block. Now this is metallic object above 5 centimeter above this glass plate. It makes to fall on this glass plate. Let's say the mass of this object is 20 kg. Let's say the mass of this object is 20 kg. 20 kg. Okay. Example. Just an example. Now when I make this object to fall 20 kg on this glass plate, will this glass plate break? Okay. Will it break? I don't think so. Will it break because the distance here are very close. Just you lift it again and you remove it, then it will fall again on that plate. Then will it move with so much force or will it move with so much velocity? I don't think so. Then here mass is how much? 20 kg, and velocity here are very less because it doesn't have times to fall. Because if you take an object to fall, initially move slowly and increase the speed. Object, remember, while it falling down, the speed are keep on increasing till it hit the ground. Okay, then here only 5 centimeter, it doesn't have times to increase the speed. Then only small amounts of velocity are there. And velocity here are very small. Then this plate does not break. Now, example, if this object I will raise it to at this point. Let's say from here to here is above. Let's consider only 10 meter. Let's consider here 10 meter. Now this object makes to fall here on this plate. Again, what's the mass? 20 kg. What's the mass of this object? 20 kg. Now will this plate break? Yes. Now, because this object makes to fall is half times to increasing the velocity t. Then when the velocity are increasing, then the force of impact are very high. Example, you take a marble and you hit a chicken by your hand, or you hit the wall. Will that wall make a hole with when you throw take a marble in your hand and throw the wall? Will that wall make a hole? No, because you give some force, you apply, and that will produce a very much velocity, but that velocity cannot exert that wall. But if you take a gun, with us, example with that marble, if you shoot it, it will run at very large speed. Then that speed will give a very large impact on that wall. Then that wall makes some hole. Okay, then that impact, what makes this glass plate break is due to the large amount of velocity. What makes this glass plate to break is due to the large amount of velocity. And the large amount of velocity there are a greater impact on this glass plate. Then this glass plate are break. Then that impact is called momentum. Here, what makes the impact very large? Due to velocity. Okay, but if I take another object of mass 500 kg, will I need to take this 500 kg above 10 meter to break this glass plate? No, only 5 meter. When I drop it, this glass plate will break. Why? Because here the impact are very large due to what? Due to 500 kg mass. Then here, in this case, while the object glass plate break due to high velocity. Now in this case, why this glass plate break due to large amount of mass. Then velocity, large amount of velocity create a large impact, give a large impact of force. And if if a mass also very big, then give a very large amount of force. Then that types of force that due to velocity or that types of force due to mass is called momentum. Here the product of mass and velocity will give the momentum, mean the impact of the object to another object. That will be called as momentum. Now what mean? P is equal to mv. P is equal to mv, very simple. But now when you explain, we go deep the concept. Now you got it. When that glass plate are hit by a marble at some distance, maybe it won't break. But if you increase it, then it may break. Because why? Because due to a very large amount of velocity, meaning give a large impact. Then that impact of force due to velocity and mass is called momentum. Okay. Now what's the definition of momentum? We can see the force or the impact produces by the force. What is this force or impact? Force means impact that push the wall or push the object or hit any object. The force or impact which produces due to the combined effect of mass and velocity is called momentum. What is this? It's called momentum. I mean the combined effect between the velocity and the mass will give the momentum. Okay, or we can say, what is momentum? The product of mass and velocity is called momentum. The product of what? The product of mass and velocity is called momentum. And that is momentum. Symbol, remember, the symbol for momentum is P. P is equal to mv. Now m stands for mass of the object and v stands for the velocity of the object. Then SI unit. SI unit. What is SI unit of mass? SI unit of momentum. Remember, this momentum we're talking here is only about linear momentum. Remember, there are angular momentum and linear momentum. But here in class 9, we will deal only linear momentum. We will know about angular momentum. Then SI unit. Then linear momentum. Okay, what's the SI unit of mass? SI unit of mass will be kg. Always in kilogram you measure it, not in gram. Then what's SI unit of velocity? You already learned it in previous chapter. SI unit of velocity is meter per second. Meter per second. This is the fundamental unit of momentum. And one more. It is a scalar quantity. Scalar, no. It is a vector quantity. It is a vector quantity. Remember, momentum is a vector, meaning it has a direction. Okay, now you have name of momentum. Then SI unit is kg meter per second. Remember, mass is kg and velocity is meter per second. There is another form we can convert this one. Kg meter per second. Can we convert it in some other form? Can we convert it in some other form? But these are the fundamentals, fundamental units. But maybe you can try somewhere. Okay, let's see later. Now we got the meaning of momentums. What is momentum? It is the impact given by velocity and mass when it hits some object. Okay. Okay, now let's start with Newton's second law. Now we come to Newton's second law. Now you already know what is momentum. It is combined effect of velocity and mass. Second law of Newton. And remember, from all the laws of Newton, first law, second law, and third law, remember this second law are very, very important laws. You will be use it so many times in the next chapter or next topic, and also will be used very much in higher classes to derive any types of equation of motion for any particular object. Always we will start from this equation of Newton, second law of Newton. And remember, Newton's third law also is important, but remember that Newton's third law is mostly give the nature of force. It just give what is the nature of force, the characteristic of force. First law give the definition of force. Now second law, what is it? Let's look here. Okay, you already understand what is momentum. Now here, what is Newton said? He says that remember in the first law said when the object is at rest, it will remain at rest until unless some external force are applied. Now what he said in Newton's second law, he said that the object will move. Okay, now this is object at rest. Now once I apply force, now this object will move, right? Once I apply force, and remember, the object moves in the direction of the applied force. That is one case. Now if I push the object this side, pushing that direction, then the object also moves in that direction. Okay, according to this law. If this is object, now this is at rest, now the force are coming and pushing. Then this object moving on that direction of force. And also, when this object moves, it moves with some velocity, with some acceleration. Then the moment once it moves, it gives the product of mass and velocity, right? Now we already talked about momentum. Then once we push this object, it moves. It has some velocity and it already has some mass. Then it produces a momentum. And remember that once we apply a force, then the momentum move is directly proportional to the applied force. Now, if the force are large, then the momentum also will be large. And also, if the momentum are very large, then the applied force also very large. Okay, mean that is a Newton's second law. It means this object is at rest. Now, if I push it, then how much it can push? It depends on, okay, example, how much force required so that I can push this object? Then that force has to be greater or equal to the momentum of the object. Means we can say that it states that the momentum of the object, the momentum of this object are directly proportional. What is that? This momentum is directly proportional to the applied force. Mean if the applied force is more, then momentum also will be more. Now if the momentum will be more, then force also will be more. That's mean of this. What is this that? Okay, still Newton's second law. It states that the applied force is directly proportional to the momentum or the momentum of the object. Okay, I'll do like this. Momentum, the rate of change of momentum. The rate of change of momentum is directly proportional. The rate of change of momentum is directly proportional to the applied force. What's the meaning of this rate of change? The momentum is directly proportional to the, if the force are more, then momentum also will be more. And if the momentum will be more, then force also will be more. Then what's the meaning of this? rate of change of momentum. Because whenever the object moves, remember we always compare any things what we did. We always compare with some reference point or some reference frame. Then here we take a reference with rate means time. Means once we apply a force, then this object are moving. Then at a particular time, how much is the momentum? Then initially the momentum, let's say initially, now here is object. Now here initially the momentum maybe somehow mu. Example, here is the momentum initially. Now once you push it, now this will move. Let's say here will come to mv. Now this is a new momentum. Now what's the time here? Time t. Then at this particular time, what is the change? What is the change in momentum? What's the change in momentum? mv minus mu. That's the change. Change means difference. This is the final momentum, then this is the initial momentum. Then the rate of change of momentum is directly proportional to the applied force. Provided the object move. When it move, what is that? If the applied force is pushing direction, then the object also will move that direction. Provided that the object move along the direction of the applied force. Now this is the second law. First law, the object will remain at rest. The object will remain in uniform motion. But here, the momentum is directly proportional to the applied force. And one more, the object will move in the direction of the applied force. The object will move in the direction of the applied force. Then from here, I can do like this. It's directly proportional. Mean rate of change momentum. Okay, I can do like this. Momentum is directly proportional to rate of change of momentum. Means momentum. Okay, I can do like this. Momentum divided by time in change. Change momentum divided by time is directly proportional to the applied force. Or this we can write in mostly in higher class. We do like this: dp by dt is directly proportional to F. Okay, but we don't write like this. Now, remember what is SI unit of force? SI unit of force is, maybe you know it. Then here, remember the SI unit of force is Newton. Now we'll come to that. Okay. Now, consider an object of mass m. Consider an object of mass m moving. Consider an object of mass m moving initially with velocity u and final velocity v at time t. Okay, consider object of mass m moving. How I wrote here? Moving with initial velocity. Moving with initial velocity u and final velocity v at time t. Okay, let me rub this part. Let me draw a diagram here. Consider this is the object of mass m. So this is object of mass m. Initially u. The velocity is u. Okay, so this is at point A. Now, once we apply the force, okay, consider an object moving, consider an object of mass m moving velocity, initial velocity u and final velocity at time t, due to what? Due to the applied force F. Now, why does the object move? Due to the pushing of the force. Now, let's say here F. Then this object will move till it reach to position B. But this object are the same, right? Because this object are involved till it reach here. Then this will reach at point B at time how much? Time t. Okay. Now here the velocity will be v. Consider object of mass. Okay. Now why this object are moving? Why this object are moving? Due to the applied force F. Then it moves initially with u, then to the final velocity v at time t. We consider only at some time, not whole day. That will move forever. We just take at a particular time. Okay. Now according to statement. I write that only. You already know what's the meaning of change with minus. Okay. According to statement, when applied force is directly proportional to the rate of change in momentum. Rate of change. Rate when you already know what time t. Then change in momentum. Change in momentum. Okay, now about the statement, force is that change in momentum by time. That's meaning of rate of change in momentum. Being change in momentum divided by time. Okay. Now under this. Now F is directly proportional to change in momentum. Change in momentum means here this is the final momentum here. Okay, let's here let me put here PF final momentum and here is PI initial momentum. Final momentum, initial momentum. But final momentum is what's the formula for momentum? We already did just now. That is product of mass and velocity. That is mv. And here is mu. Then change means minus. Remember here, mv final momentum minus initial momentum divided by time. Okay. Then here we got F is time proportional. Now here also M, here also M. Then again I can take common that M and left here only V minus U by T. And what is V minus U by T? This formula has been familiar for you. This formula you have did it in previous chapter. That is about motion, topic motion. Okay. Then here we write F is directly proportional to M. F is directly proportional to M. Now V minus U by T. What is this? I can write directly. What is this V minus U by T? This is A. What is this A? Acceleration. Since A is equal to change in velocity by time. What is acceleration? It's a rate of change of velocity by time. Then what is force now? Force is proportional to mass into acceleration. Now remove this proportionality. We have F is equal to K. What is this K? Removing this proportionality, then you got this value K. What is this K? Where K is equal to constant of proportionality. Constant of proportionality. but simply we call as only constant. What does this K stand for? Constant of proportionality. Okay. Let me take here that F is equal to 1. That F is equal to 1, then M is equal to 1 kg, and A is equal to 1 meter per second square, because SI unit of acceleration is 1 meter per second square. Then F is equal to 1. 1 is, remember, the SI unit of force is Newton, then I put here Newton. F is 1. Just assume that F is equal to 1, then M is equal to 1, and A is equal to 1. Then what we got here now? In place of F, I'll put 1. In place of K, in place of M, and in place of A. Then how much we got 1 of K? And therefore K is equal to 1. And thus F is equal. Now in place of this K, I put here 1. In place of this K, put 1. Then what left here? Only F is equal to MA. Now this is the formula of force. And what is this law give us? Now this law give us the magnitude of force. First law, definition of force. Second law, magnitude of force, mean the value of force, how much force it is. What is the amount of force? This law give. Second law give the amount of force. Now remember, this force is valid only for a unit mass, unit acceleration. Remember, this force holds good only for unit mass and unit acceleration. Okay, and then or we can define more force. We already find what is force. Force is the external agency which tends to change the state of rest, change the state of motion, change the state of direction, change the stop motion. So many effect that force do. And in first law, force produce motion. It said that when an object is at rest, it will remain at rest until some external unbalanced force are applied. Okay, but here we can define in another form what is force. Force is the product of mass and acceleration. What is force? The product of mass into acceleration. Now this will be the, okay, then note it is a vector quantity. It is a vector quantity. Remember, force is a vector quantity. And what's SI unit of force? Newton. But SI unit of force is Newton. But let's take the fundamental units. And SI unit. What's SI unit of mass? kg. What's SI unit of acceleration? Meter per second square. Now these are the fundamental units of force, or simply we write Newton. N. Newton. Do check here. Symbol I write with capital, but full I write with small letter Newton. Don't write with capital Newton, capital N here, Newton. If you write with capital N, it means the name of a person. But here small n I put. But for symbol we put capital. But here to write a full, we write in small letter. Okay, that denotes the unit. Then in that SI unit of momentum, P, we got kg meter per second just now, right? Kg meter per second. But now this kg meter per second, I can change it into another form. I can go like this: kg meter per second. Let me multiply second by second. Now this SS and cancel. But here I can note this: kg meter seconds. S into S will be S square. Or can write like this: S. Now S into S square. Now what is this kg meter per second square? Kg meter per second square is Newton. I can write here. This whole thing become Newton. Then left this here S. Now what is the SI unit of momentum? What is the SI unit of momentum? Newton second. That's the sign unit of momentum. What's the sign unit of momentum? Newton second. Or the fundamental units is kg meter per second. That is the when I explain that momentum, I just give you this is just SI unit. I'm not yet explaining you this Newton second because you have not yet learned what is a fundamental unit of force. That's why I'm not yet explaining this Newton second. Now, do note that in that what is the momentum in that SI unit, you can write this kg meter per second or Newton second. Newton second. What's the sign unit of force? Newton. What's the sign unit of momentum? Newton second. Okay. Now, these are the second laws. What is first law? It defines force. What's second law? It gives magnitude of force. And remember, these second law are very, very important laws. And remember, these second laws is called as a real law. There are three laws: first law, second law, third law. But remember, second law of Newton is the real law. Let me ask you why this law is said as a real law. Because Newton's second law contains both first law and third law. Okay, when I finish to explain about third law, I'll show you how that first law is present within the second law. In first law, it defines that when objects are at rest, it will remain at rest. But here, the rate of momentum is proportional to the applied force. Then how that things are related to first law? Okay. And remember, first law is contained within the second law, and third law also is contained within the second law. But I will show you, according to the syllabus, it's only first law. It shows that it is contained in second law, but third law also contained. Okay. Then I will come to third law. But before we come to third law, first we have to understand one more term: impulse. We finish first law. Before we do first law, in previous video we have talking about inertia. And remember, first law is also called as the law of inertia. First law is also called as the law of inertia. And first law is define the meaning of force. Then second law is called as a real law, and it gives the magnitude of force. And third law gives the nature of force. Okay. Now, but when we start to do first law, we already did inertia. Now, when we start to do second law, we did momentum. But now, when we start to do third law, we will do impulse of force. Okay. But this impulse of force, it does not. Like what I said. They are not related to so much important for third law, but at least you have to know something what is impulse. Okay, it's not related too much for third law. Okay, but you have to know what is impulse. Now let me drop this one, then we'll start with impulse. Okay, now before we start Newton's third laws, let's do first this impulse. Now this impulse is the application of Newton's second law. And did you remember in momentum the combined effect of mass and velocity? But here in impulse it is a combined effect of force and time. The combined effect of force and time. Okay, momentum is the combined effect of mass and velocity in momentum. In impulse, combined effect of force and time. Now that is the difference. Okay, now momentum is the impact that makes the object to break. But impulse, I can say, it is the force observed by the object at a particular time, at an instant of time, I can say. Example, when you catch a ball, when ball is coming, fall towards your hands. Did you put your hand like this and catch the ball? or did you do like this to catch the ball? Remember, if you put your hand like this directly to the falling ball, means all that force which comes from that ball is exerted to your hand, and your hand will absorb that large amount of force in just a small interval of time. Mean large amount of force in just a small interval of times. Then if in that case large amount of force in just a small interval of time, then that force will make your hand to get hurt, or it may lead also to fracture. Maybe your finger will get wounded, or you'll get hurt. Okay, then to reduce that large amount of force to absorb by your hand in just a second, then you give time to absorb. Then when the balls come, you catch it when you keep your hand to move downwards. Why you move your hands down or back? That means why you move your hands down means you increasing the time, so that force it won't absorb directly at just a small interval of time, so that force will absorb in a very long time. Then so that your hand won't get hurt. If it suddenly absorbs, then your hands get hurt. And the impulse means the absorption of force at a particular time. Okay, then impulse is combined effect of force and time. Then if the force is large, then to reduce the effect of force, you have to increase the time. To reduce the effects of force, means to make that force absorb are very small. If the force are very large, then you have to increase the time. Okay, but if the force are very large and also you give the time are very small, then in that case, the force, that large amount of force are absorbed suddenly. Then it will get hurt the whatever absorbed. Example, if you fall from a story building, from 1 story or 2 story, if you fall on the sun, let's say you won't get hurt too much, because when you fall, that sun will yield down. Then it have that force of impact, that force absorbed will have time, because the sun will get yield. But if you fall on a hard ground, then that hard ground never yield, then it will hit directly, and also a large amount of reaction also given back to you, that we will do in Newton's third law, reaction force. And that force are fully absorbed, completely absorbed. Large amount of force are completely absorbed in just a second. Then it may harm, or it may leads you to fracture, or it may even leads to death if you fall from a 1 story or 2 story building. That is due to impulse. That types of force that absorbed by another object but after impact, that we call as impulse. Okay, now let's define this. Okay, what is it? What we said, that impulse of force is the combined effect of force and time. Combined effect of force and time. Okay, let's start first with definition. Definition: impulse of force. Okay, what's the definition? What is the definition? The force acts on the body for a very small duration of time. A force acts on the body. Okay, now this force acts on the body for a very small duration of time. If that whole force are acting for a very small duration of time, what's happen? It will get hurt to the body who get acted by that force. Okay, the force which acts on the body for a very small duration of times, but produces, what it produces? It produces a significant change in its momentum. Okay, what do you like? What do you like? The force acts on an object for a small duration of time. Small duration of time, but produces a significant change. In momentum. What is this momentum? It's the impact. And this momentum will create an impact on your hand, and your hand get hurt when you catch a ball. Okay? What produces a significant change in momentum is called impulse. It's called impulse of force. And what is SI unit? We can write this. SI unit. SI unit is Newton second. What's the SI unit of force? Newton. What's the SI unit of time? Second. Now SI unit of impulse and SI unit of momentum are the same. Remember that. Which of the following physical quantity has the same unit? If they give you option on this. Which of the following physical quantities has the same unit? A. Force. B. Momentum. C. Impulse. Force and momentum and impulse. Then impulse and force, option number D. Then energy and momentum. Example: which of the following physical quantities has the same unit? What's the answer? Option number B. Momentum and impulse. Because in momentum also we saw Newton first, Newton second. And here also we got Newton second. Then impulse and momentum are the same. Are the same in nature also. Okay. But here, force into time. But remember, when you hit a hammer, when you hit a nail with a hammer, let's say this is a nail and this is hammer, you hit it like this. Can you measure how much time, up to how much time this hammer stuck on the head of the nail? Can you measure that time? It is very difficult to measure the time. If you know the time, then you can measure what is the impact or what is the impulse of force that makes that nail to penetrate inside the wood. Okay. Then in that case, to measure times are a very difficult task. Then this formula, maybe we cannot use it in realities. Then we can make other forms of formulas. Okay. Because time are very difficult tasks to measure because it's for a very small interval of time. Example, when you catch a ball suddenly like this, also can you measure the time? You cannot measure the time. Because it's just for a second, just for millisecond. Millisecond is very, very small. Okay. Or microsecond. Then in that case, we convert this formula in another form. Our impulse is equal to force into time. But what's the formula of force? Force we got ma. You remember in second law, force is equal to ma. And what is A? What's the formula for A? V minus U by T into T. This T is here. Now this is This is from where? This is from A, acceleration. Now this T and T cancel. Then we got here M into V, then M into U. Then we got I. Then here, impulse, what is this? MV minus MU. Then I is equal to change in momentum. Then that is, you can say, an impulse of force. Impulse of force is equal to change in momentum. Now what's impulse of force? Impulse of force is equal to change in momentum. Then it is very easy to measure this change in momentum than time. Now you got ring of momentum impulse. Now remember, this impulse is the application of second law of Newton. You can check from your textbook also. So there are two examples related to impulse. You try to read that topic, and that question may be very important for you in the exam. Why, when a cricketer catch a ball, they move their hands backward? When they catch a ball, they move their hands backward. Why? Already explained why. To increasing the time. Why increasing the time? To reduce the absorption of force. Okay. Now we'll come to Newton's law. Okay, now continue from that, and we'll start Newton's third law now. Okay, Newton's first law gives the definition of force, and also called as law of inertia. Then second law gives the magnitude of force, and it is sometimes called as real law. And now will come what is Newton's third law. And what is Newton's third law? Newton's third law gives the nature of force. Remember, force can never occur single. Can you believe that? Force, it does not occur alone. Then you may say, why? How? Force can never occur alone. Look, whenever force occurs, remember there is always two force. Force are always exist in pairs. Force are always exist in pairs. From where that began? It is from Newton's third law. Newton's third law said it gives the nature of force, and also said that force never exists single. It always exists in pair. What do you mean that in pair? Example: if you punch a wall, you apply a force. That is just a single force. You apply a force. But once you punch the wall, then will your hand get hurt if you punch hardly? Yes, your hand will get hurt. Then why get hurt? Because there is another force that will be called as reaction force. That force will push back, will give back that force to your hand. One force is this direction, one force is direction. Always occur in pair, not only one force. Now, if example, this object, now I'm pushing this object this direction. You said there is only this force? No. There's one more other force. That force is by this object itself. It's trying to push my finger back. Okay. But due to this force are very large than that, then this object is moving that direction. And what is that force? It's a friction. Friction also itself does not occur. By itself it is called as a self-adjusting force. Friction is a self-adjusting force. Once you push, then that friction automatically it comes. Why it comes? Because force never occurs single. Because this is only one force. Now once you push it, then there's a one force coming out to access that force. That will be the friction. That's because friction is a self-adjusting force. Automatic it come out. Then remember, force does not occur single, it always exists in pair, and this third law gives the nature of force. And what is that? Newton's third law. Newton's third law of motion. And this, what is that? To every action. What is that? What is that action? Action means a first person apply a force. Let's say that is action. Action means I can say initial force. Okay, initial force apply to another object, and that object also give a reaction force. That reaction force is the final force, I can say. Okay, then to every action there is an equal and opposite in reaction. It states that to every action, action here means initial force. Okay, to every action there is an equal opposite in reaction. Now what's this reaction? Now example, this is a wall. Example, this is a wall. You give a reaction here. What action force? Action force, you can say initial force. Now this force are pushed to this wall. Now this wall also will give a reaction force. A reaction force. Remember that is force does not occur single, does not occur alone, always occur in pair. And why? When we stand, when I stand like this, where I stand on the ground or on the floor, I give the action on the floor. And remember, the floor also gives a reaction back to my feet. Example, here there's a person. Now this is standing here. Apply this person apply force downward. This will be the action force. And remember, this ground give again a reaction force. This is action force, and this is a reaction force. And remember, this reaction force is always equal to action force. If imagine reaction force is greater than action force, then what happens to this person? This person will fly. But it never happened like that. Then reaction and action are always equal and opposite. Action is downward, reaction is upward. But if I point the wall like this, then my action is that side, this force is action, but reaction will come this side. Then action and reaction are always opposite. That is, I can do like this. That is F12 is equal to F21. I'll explain what is this F12 and F21, okay? Okay, now I'll explain what this is F12 and F21. This is the Newton's law. Newton's first law. F is equal to ma, and Newton's second law. Newton's first law, there's no formulas. I just wrote it as V is equal to U. This is first law. Then this is second law. Now third law, I can write F1 is equal to F2 or Fa is equal to Fb. Okay. This is third law. What does it mean F12 is equal to F21? Let's see here. Let's say this is object A or object 1. Okay, object 1 and this is object 2. Now these two objects are interact. What's the meaning of interact? When one object is influencing the another object by exerting a force, that is called interaction. What is an interaction? When one object is influencing another object. When one object is influencing another object by what? By exerting a force. It's called interaction. Okay, let's look here. Imagine this, now this force is interact with this object is interact with this object. Let's say this is object 1, this is object 2. Now this object 2 also interact with this object. Now this object 1 is pushing this object 2. How much force? F21. What's meaning this? Let's say this F21 is the force exerted on 2. Exerted on what? On object 2. Force exerted on object 2. By who gives that force? Object 1. Then force exerted on object 2 due to object 1. Or I can write this, okay, but I'll give like this only. Now force exerted on 2 due to 1. Force exerted on object 2 due to object 1. Now this, let's say this is the action. Now that is the action. Because this object is pushing object 2. Now this object 2 will give a reaction. Then this object 2 will push this side. Now that will be like F12. Mean force exerted on 1, on object 1. Force exerted on object 1 due to object 2. Now let's say this will be the action, then this will be the reaction. Got it? Then what is interaction? When one object is influencing another object by exerting a force on it, it's called interaction. Okay, where? What is F12? F12 is the force exerted on object 1 due to object 2. That will be, okay, you write here. Force exerted on object 1 due to object 2. You can write this in bracket, reaction. Then F21, force exerted on object 2 due to object 1. You can write this in bracket, action force. This is action force, and this will be reaction force. Got it? Then can we note here? Now we'll note here. This third law. Third law gives nature of force. Nature of force. Remember, third laws give the nature of force. What's the nature of force? Meaning always acting opposite. And what it gives? Always axis impaired. And what the second law gives? Magnitude of force. Magnitude of force. And what first law? Definition of force. Now this are the, but this law sometimes called as law of inertia. Then this law is real law. Okay, and from here there's some important question. Let me ask you an example. Why is easy to work in a hard ground than in a sandy soil? Or why it's very hard to work in a sandy soil than in a hard ground? Remember, force, action and reaction. Because when you work on a hard ground, you give an action on the ground, right? Then that ground suddenly gives you a reaction. Then easily you can move. Then it's very easy for you to move. Because you give the action, the ground gives you the reaction. But in a sandy soil, if you apply force, you give you the action on that sandy, then that sand will yield. Sands will yield. Then once it yields, the reaction force given by that sand are very, very small compared to what you have given the action force. Okay, reaction is there, but it will be smaller. Then in that case, it's very difficult for you to work in a sandy soil. Okay, you look, there are some types of question, example they given in textbook, you can read from there and try to relate with this formula, with this statement, and when you will understand it more. Okay. And at least remember this: third law gives definition of force, second law gives magnitude of force, and first law gives the definition of force. I have told you that second law is the real law. Why? Because it contains both first law and third law. Second law is not real law because it contains both first law and third law. Then I told you how that second law contains first law. Now we will do it. Okay. Then after that we'll come to last part of this. Then we'll continue this topic, this chapter in next class. Okay. Let's rub first this one. Okay, now we'll do that. Second law is the real law. Then show why is real law? Because we contain both first law and third law. Then we'll show here now how that first law is contained in the second law. But third law we won't show because it's not yet in the syllabus. In your syllabus. Okay. Now question. Obtain or derivation or obtain the first law of motion from second law. Okay. Now, let's do like this. We know F is equal to MA. This is according to second law. This is from where? From second law. What is this F? Applied force. What is this M? Mass of the object. And what is this A? Acceleration. Okay, I write here where F is equal to applied force and M is the mass of the object. Then A is the acceleration of an object. Okay, let's take this as equation 1. But this is from second law. But in first law, we said that the object, if it's at rest, it will remain at rest. Got it? Okay. Mean there is no force applied. Means let F is equal to 0. Mean the applied force is not yet there. Now put it here in this equation 1. And from 1, but here 0 is equal to MA. Or I can write this, or MA, or MA is equal to 0. Now M, what's the formula for A? Is V minus U by T. This is formula for A. Final velocity minus initial velocity by time is equal to 0. Now take this M that side, or dividing through out by M. I can do this. V minus U is equal to 0. Take this T, multiply, and take this M will be divided. Then 0 into T will be 0. Then 0 divided by M will be 0. Then got here V minus U is equal to 0, or V is equal to U. Now did in first law is this one, that V is equal to U. Okay, now what is the meaning of this? What's the meaning of this? Means the body will be at rest, or the body will be in uniform motion. Now if U is equal to 0, then V also 0. It means the body will remain at rest if external force is equal to 0. But if U has some values, then V also will equal to that U. Then it shows that the body will keep on moving with uniform speed or uniform motion. Now this will be the first law. Now first law is contained within second law. Okay, now we come to next part. That is the definition of Newton. Define define Newton or define 1 Newton or state the SI unit of force and define it. Let me give that question. State the SI unit of force and define it. The SI unit of force is Newton. Then define it. Okay, to define it, we're like this. We know F is equal to MA. F is equal to MA. Then let M is equal to 1 kg. Then A is equal to 1 meter per second square. And therefore F is equal to 1 into 1, which is equal to 1 Newton. Now how do we define it? Thus, when a force of 1 Newton, when a force of 1 Newton produces an acceleration of 1 meter per second square for a unit mass of, for an object of unit mass, or how do we define it? Okay. A force is said to be 1 Newton. Okay, we define this. This F is stand for force. Okay, a force is said to be 1 Newton. 1 Newton. When it produces an acceleration of 1 meter per second square for on an object of how much? On an object of mass 1 kg. That will be the definition of Newton. Okay. If you ask you state SI unit of force and define it. SI unit of force is Newton, write that, and definition is one. Okay. Why I write this for you to remember? A force is said to be 1 Newton when it produces an acceleration of 1 meter per second square on an object of mass 1 kg. Okay, what else? Is there anything else we left from here? What is in the interaction? I'll be explained. Let me check from your textbook what is missing here. Okay, now this much only maybe. If is there any missing part I forget, then I'll explain you in the next video, because in that we'll do the last part of this chapter, that will be law of conservation of momentum, and we'll do the simple problems on the update. Then after that we'll finish this chapter, then we'll start with gravitation, chapter 3. Thank you.